All right, so real quick here, I want to take a look at just a couple problems, finish up what we started yesterday, and then I'm going to let you work. Let you grab a Chromebook and just work, get some stuff done. Okay, so what about this guy here? What are we going to do? This is a little bit, kind of a little harder problem. We looked at some stuff like this the other day. Now keep in mind, this one is not like that one. That one was pretty easy. I mean, well, it's easy, but easier because nothing is being multiplied, nothing's being distributed, right? So all we had to do here was just multiply through by a number to clear the fractions. Agreed? Okay, this one, we looked at an example yesterday. This is a little different. We're distributing stuff, distributing fractions. So there's not one way to do this, but what's our best strategy here? What do you think? So, okay, we're going to clear fractions, but remember what happened yesterday, I guess. I don't know if I still have those notes. I guess I don't have those notes up anymore. If we tried to clear the fractions before we distributed, we ended up having to clear them twice, right? So if we have to, if we've got stuff that's being multiplied by a quantity that we have to distribute, just slightly easier, just a good strategy, let's just distribute first and then clear the fractions, right? I know that we're going to be multiplying fractions, and that doesn't sound great, but multiplying fractions is really pretty easy. It's adding and subtracting fractions that's the hard part, right? So if we distribute then, if we multiply the 9/8 times 4, what do we get? I can do a little bit of simplification, right? 4 over 8 reduces to 1 over 2, and then I just get, pretty great, I just get 9/2. So I'm going to end up, when I distribute to the 4, I'm just going to get 9/2. What about when I distribute the 9/8 to the 1/2? I just multiply straight across. So 9 times 1 over 8 times 2. Everybody agree? 9/16 A, I've got an A there, right? Equals, if I distribute the 3, that's the same as 3 over 1. So what's 3 over 1 times 1 over 4? 3 over 4. And I've got an A. And then finally, 3 over 1 times 5 over 2. What's that going to give me? On top, I'm going to get 15. On the bottom, I've just got 1 times 2. So there, we distributed. Now, we're to a point where we can just clear all the fractions, right? And it'll work, because nothing's being distributed anymore. So what's the biggest, look at all the denominators here, and take a second and just think about this before you tell me an answer. What's the number I'm going to multiply by both sides? So what's the least common multiple of all the denominators, the least common denominator? John, what do you think? What's the smallest number that all of these would divide into? 2, 16, 4, and 2. 16. Good. So we could distribute a 16 through both sides. Now remember our trick for this. It makes this easier when you're clearing fractions. We can always reduce first and then multiply by the top, right? So 16 over 2 reduces to what? 8. So we can cancel the denominator. And I just like to put a circle around that and point at the top to remind me what I'm doing, right? I multiply the top by 8, and what's that give me? I've got 9 on top times 8 is what? 72. Okay, so the first term just becomes a 72. 16 over 16, 1. Times 9 is 9, and I've got an A there, right? 16 over 4. That reduced 2, good. So I get a 4 times 3A, what's that? 12A. And then 16 over 2, 8. 8 times 15. Now let's think about that, about the mental math part of it. If you're multiplying by 15, that's hard to do in one step. What could you do instead? Suggestions. Times 10. Isn't that good? So multiply by 10, multiply by 5, and add them up. right? So 16 times 10 would be what? Or, sorry, 8 times 10. 80. 8 times 5? 40. 80 plus 40? 120, there you go. And once we get rid of the fractions, it's a piece of cake now, right? No big deal. So let's think about this in terms of our order of operation stuff we talked about yesterday. And once again, I know these are easy problems, but they're gonna get harder throughout the year, so let's always think about this in terms of a process. So what do we gotta do here in Y to proceed? We gotta get it down to one variable. I've got multiple x's here. I got two separate x's, and I gotta have a single x. Once I get a single, or a in this case, not x. Once I get a single a that I can point to, I can isolate it, right? But I gotta get there first. So I've gotta start off by simplifying. There's really only one thing to do here. What's that? Say it again. Add 9a. Yeah, we gotta combine the like terms. There's no parentheses, there's no exponents, there's no multiplication, but I can add up like terms to get a single a. So if we add 9a to both sides, we get 72 equals, what's 12a plus 9a? 21a. Plus 120. So now we can isolate. We've got a single a, so I can just reverse order of operations and solve for a, right? Isolate a. What are going to be the two steps in order to get the a by itself? Okay, so subtract 120 and then divide by 21, right? Okay, so if we do that stuff, -72 minus 120, -48. So you told me the last step then would just be to divide by 21. And so my answer is -48 over 21, but can we reduce that fraction?
Yes.
We can't we? The digits on top, 4 plus 8 is 12, which is divisible by 3. So I know 3 goes into 48, and obviously 3 goes into 21, right? So if I divide top and bottom by 3, what do I get? 48 divided by 3, 16. 21 divided by 3. There we go. Okay, question? There's a lot of stuff going on there. You'll get a chance to practice that on the Moodle homework. Let's take a look. I want to just real quickly look at two very simple problems, but it's not the problem we're interested in, it's the result when we solve these things. Watch what happens. So here I've got multiple c's. I'm going to have to simplify, agreed? I got to go down the list first. So inside parentheses, nothing I can do, no exponents, but there is some multiplication. Right, I got to distribute the 5. So I'm going to get 1 plus 3c equals 5 minus 5c, that look good? Plus 8c. So we did multiplication. Last step, we'll add and subtract like terms. What's on the right side? -5c plus 8c is what? 3c. So we end up with 5 plus 3c. Okay, this is something weird happens here. Normally we would push all the c's to one side or the other, right? But this time what happens when I subtract 3c from both sides? They go away. All the variables disappear and I get the answer 1 equals 5. What's that all about? We did it correctly. We did the algebra correctly, and that's the answer we're supposed to get. But how do we interpret that? That's a different kind of answer. Usually we're used to something like c equals 7, right? We get a number answer. This time there's no variable in there, and we get the result 1 equals 5. Is that true? That's false. How often is that false? Always, right? It's always false. So what do you think how do we interpret this? What are the values of c that are going to make this equation true? Are there any? There are none. That's how we interpret that. When we get a false answer with no variable in it, that means there are no solutions. Nothing is going to work. No value of C you could ever pick that's going to make that equation true. Okay? No real numbers or no solution. Let's say no solution. Okay? How about this example over here? Same kind of thing. This one's a little bit easier. All I've got to do over here is just distribute the -8, right? I've got multiple x's though, so I got to simplify. If I distribute the -8, don't I just get -8x plus 40? If I subtract, or if I add 8x to both sides, what's going to happen? Yeah, I get the answer 40 equals 40. Is that true? Okay, it's true, but we didn't get an answer in terms of the variable. So what do you suppose, how do we interpret this?
Variable can be
It could be anything, right? It doesn't matter what you put in for x, anything is going to work. So we'd interpret that to mean all real numbers. Okay. And on Moodle, when you answer these, what you're going to see on this assignment, if you get no solution on Moodle, they just want you to put in a capital N, just a regular capital N. Doesn't need to be anything fancy. For the all reals, I asked you to put in the number, the symbol that corresponds to the set of real numbers, which is different. It looks like a capital R, but it's really this fancy kind of double struck R. I'll show you where to find it. So if you want to enter that answer, I'll just pull up some random question. Doesn't matter what the question. Oh, that's a bad question. No, it's not going to work. Don't worry about the question. I don't care about that. It's where do you get that symbol? All you do is you go up to the symbol menu where it's got a pi, and you just choose, like if you hover over these things, it tells you what each one is, right? Like that weird double struck N is the set of natural numbers. There's the set of integers, etc. Well, that's the one that stands for the set of real numbers. But notice it's really not just a plain old capital R. It's kind of fancy. So that's what you would enter. Okay? Make sense? Okay. All right, last issue. Well, actually, two more really quick. Okay, when you have a problem like this, these are easy. Okay, if you have a fraction equals a fraction, that's what we call a proportion, right? Remember that from Algebra 1? Now that's different. If I do something like, say I add a -3 there, that messes it all up. That's no longer a proportion. Now it's not a fraction equals a fraction. It's a fraction equals a fraction plus some other stuff, right? That makes it a little tougher. But if we don't have that other stuff there, if all we have is this, can you remember how we solve a proportion? There's a really simple way we can get rid of the fraction here. I know you've done this a bunch, but it's probably been a long time. What do? You start with the proportion. Our goal is always to get rid of the fractions if we can, right? Remember cross multiplying? Okay, if we cross multiply, look what happens. We're going to do that cross product times that cross product, right? So the denominator here times the numerator in the other one. What's that going to give me? So that's going to be green cross product. It's just going to be 8 times 5x minus 9, right? And the red cross product is going to be that numerator times that denominator. So 10 times 2x minus 8. Much better, right? Now we don't have fractions. All I have to do is distribute and collect like terms and then isolate, right? I won't even do it right now. But you get the idea? That's the important part, is cross multiply to make it easy. Perfect. Finish. Okay. Okay, so last issue. What if you get problems like this, where there's multiple variables? And what if the goal here in this top one is we're supposed to solve for that c equals 2 pi r, right? What if we're supposed to solve for r? Are we going to get a number answer here? We're going to get c's in our answer, aren't we? When we get the r by itself, I'm going to get all this other stuff on the other side, and that other stuff is going to include a c. That's all right. That's what the answer is supposed to look like. So all we would have to do here to get that r by itself, would you agree, is just divide each side through by 2 pi, and I get the answer, r equals c over 2 pi. That's what I would input. Okay. What if I'm solving for b? Oops. If I'm solving for b, that means I'm just isolating b. What would the steps be here? There's a single b, so I should be able to isolate it. What would I do first? It's a little bit tricky. There's something I want to remind you about here. Say it again. Multiply by a. Not yet. No, not yet. Now, there's something you got to remind yourself about. Look, I've got a big fraction here. If you reverse order of operations, it says first we're going to do any addition or subtraction we need to, then any multiplication or division, then any exponents. We won't have that for a while. And finally we get to parentheses, right? But we can't do anything inside the parentheses until we get here. So really the first things we run into, all this stuff, these are going to be addition and subtraction and multiplication and division outside of parentheses, right? It has to only be stuff that's outside of the parentheses. Are there any parentheses in this problem? They're not written, but they're there, right? Where are they? Where do we have to put parentheses when we have a big fraction like that? Say it again. Around the a, okay, around the a plus b, we have to put parentheses around the whole numerator, and we don't really need them on the bottom because there's only one thing. But they're implied parentheses around the numerator and the denominator of any fraction. So we do have some parentheses here. So we can't do anything with this set of parentheses. We can't deal with unlocking the b from inside the parentheses until we get up to that final step, right? So outside of the parentheses, that's invisible to us. Is there anything we can add to both sides or subtract from both sides to help isolate b? There's not at this point, is there? Right? The only addition or subtraction is inside the parentheses. So we're going to skip through that step. Any multiplication or division? Yeah. Well, right now, the b is on top of a fraction. It's being divided by c. How do I undo division? Multiply. Good. So I got to multiply both sides by c. And that's going to cancel the c's, right? Okay. So that gives us a plus b equals 5c. Well, now I finally get up to the parentheses, but nothing's being multiplied by the parentheses or divided by the parentheses, so I don't even really have to write them anymore. I could, but I don't have to. Just get rid of those. What's my last step then? Once I finally get up to the parentheses, what's the one last thing I still have to do? Yeah, I got to get rid of that a, don't I? We're trying to isolate b, so I got to subtract a from both sides. So those go away. I end up with b equals, well, I can't combine those, can I? 5c and a are different terms, so I just end up with 5c minus a. And that's my answer. Okay? Make sense? Okay, so the same steps we'd normally go through, you just can't simplify the numbers. You're just stuck with some symbols in there. Okay? All right, I want to let you work. Get you going. So grab a Chromebook. Get your questions answered.